Hello, welcome back. We're going to be talking about kinematics here today. Some things that you're going to find out about. First of all, we're going to talk about the four kinematic equations that are used for horizontal movement. That constant acceleration is a must for these equations to work. Otherwise, we can't use them if we don't have constant acceleration. And how to find either average velocity, a displacement, an acceleration, or a time. Okay, again, up here at the top, all of these assume constant acceleration. And I'm going to spend a little bit of time talking about that, but not a whole lot. We've only got one spot in here for acceleration. So in this equation, in this equation, and in this equation. So if there's only one spot for acceleration, that means there can only be one acceleration, and it has to be the same throughout that whole problem. We don't have a second spot to put a second acceleration if it was moving at a different rate during, or if it was accelerating differently during a different part. So when it comes to using these equations, you can only have one acceleration that you're using. Sometimes we can have different velocities, sometimes we can have different positions, but really when it comes to acceleration, we can't have different accelerations. Our first one, all right. Vf equals Vi plus At. Well, Vf is the final velocity, Vi is the initial velocity, and A is acceleration, and T is time. Notice that in this equation, or in this equation, that they don't use distance. All right, distance is not in the equation. So if I wanted to find a velocity or an acceleration or a time, and they didn't give me distance, this would be an equation I might take a look at. The next one I want to talk about here is our Vf squared equals Vi squared plus 2a xf minus xi in parentheses. This one doesn't involve time. Right? There's no time in this equation. So if I wanted to find the acceleration or the displacement or an initial velocity or a final velocity, this would be an equation I'd want to use if I didn't have time. The last equation is typically the last one I'm going to try, and this one right here doesn't have a change, doesn't give us the final velocity. Alright, this right here is typically the last one. If the first two don't work, or if the first three really don't work, that lets me know that I'm going to have to use my last one. Okay, you're designing an airport for small planes. One kind of airplane that might use this airfield must reach a speed of 27.8 meters per second and can accelerate at 2 meters per second squared. So what I'm going to do first is I'm going to do what's called make a list. I'm going to write down the information they give me. Okay, what I've done here then is I've said that it's going to reach a speed, so that's its final speed of 27.8 meters per second. Its initial speed is 0 because it's a runway. And sometimes this just has to be intuitive. You have to use your cognitive skills and realize that planes start from a stop, and that the acceleration they tell us is 2 meters per second squared. And so really what it's coming down to is we're going to have to start being able to recognize what these units are telling us. So some of this is going to come down to our reading skills. Now it says if a runway is 150 meters long, can this plane reach 27.8 meters per second for takeoff? Well, what I notice here right away is I'm not giving anything with time. There is no time. Well, that automatically, there's no time here being given to me. That tells me I have to use one equation, because these right here are going to be, these bottom three are going to be the main three equations you're going to use most of the time. Occasionally you'll use the first one, but remember, out of these three there's only one equation that doesn't use time. So I'm going to use this one right here. My Vf squared equals Vi squared plus 2a times the change in the position, or the position. So to answer this first question, I'm going to go ahead and write the equation. Let's start plugging in things we know. I know that my final velocity is 27.8. My initial velocity is 0. Plus 2 times the acceleration, which is 2. And then it's xf minus xi. Well, here's what I want to find out. I want to know, is this runway long enough? So xf is going to tell me how long my runway has to be. I want to leave xf in the equation. If we say that our runway, if this is my runway, here's the beginning. That's at the 0 meter mark. Well, that's the beginning, so I can say that's my initial spot. I can say that xi then is 0. So I don't need to include xf minus 0 is still just xf, so I can leave that out of the equation. Now it comes time, let's find out what the length of this runway has to be if my plane's going to accelerate at 2 meters per second squared, and it's going to start at 0, and has to be at 27.8 meters per second in this distance. Okay, by doing this problem here, I got xf has to equal 193.2 meters. And what that means then is that for this plane to reach a speed at 27.8 meters per second and to be accelerating at 2 meters per second squared, it's going to have to be 193 meters to get there. If it's not, then it won't be going fast enough for takeoff. So no, this runway is not long enough for takeoff. What is the minimum length that must be? Right there, 193.2 meters. Anything less than that, and this plane's not going fast enough to get into the air. Okay, a car goes from 0 to 60 in 4 seconds. Find the acceleration. Well, let's go back to our equations here. All right. I want to find the acceleration. If I want to use the first one, then I've got to know time. I've got time. If I make my little chart, start putting what they give me, VI is 0, VF is 60, and time equals 4 seconds. So I want to know, I got to find acceleration using time. Well, you got a couple choices. Obviously, the middle one's out of the question because there's no time in the equation. Just common sense now says, do you want to use the top one or the bottom one? Well, the top one looks a lot easier. So I'm going to use the top one. Also, the bottom one would require distance, and I don't got that. So let's find this. I'm going to use that equation, and that equation is VF equals VI plus AT. What we get here then is an acceleration of 15 meters per second squared. Notice that I'm writing this equation every time. As you guys are working these problems out, you need to be writing the equations. If you don't write the equations, you will not learn them. All right. Find the distance it went. Well, go back to your kinematic equations. The top one doesn't have distance. The next one doesn't use time. So notice that distance is in this one and distance is in this one. What it comes down to now is, do I have time? And yes, I do have time. You could use either one of these equations because this one needs time and we have it. In the top one, I have a final velocity, initial velocity, and whatnot. So if I don't have time, then I'd have to use this middle equation. But when I have time, I can probably use either. So we haven't used the bottom one. I'm just going to arbitrarily choose to use that one. Okay, now it's a matter, if I want to find the distance, that's my final position. Well, if we pretend that we started at 0, because it doesn't say anything else, so let's just say it is 0. I'm going to say 0. Its initial velocity is 0. Time is 4 seconds. Plus 1/2 the acceleration we just found. And the time is 4 seconds. Well, the nice thing is 0 times 4 is 0, so that part goes away. 0 plus 0 is 0, so we don't need that either. The only thing we're left with in this equation is 1/2 15 times 4 squared. So what we just found out here then is that the distance this car moves in that 4 seconds, accelerating at this constant acceleration of 15 meters per second squared, is 120 meters. We found that because we knew the acceleration, we knew the final velocity, which was 60, and the initial velocity up there, which was 0. Okay, got this motorcycle accelerates at 7 meters per second squared. It starts at 10 meters per second and goes up to 40 meters per second. Find the distance. Well, notice up here, I don't have time. This is something that's just going to start hitting with you right away. As I go back to my equations up here, the equation for not having time, no time, is this one here in the middle. Okay, what I've done here is written the equation and put the numbers in. 40 was our final velocity, 10 was our initial velocity, 7 was the acceleration. I want to find the distance, it's gone, and we can pretend that it starts at 0, which is nice because anything minus 0, well, subtracting 0 doesn't change the equation, so I can just get rid of that. So let's plug some numbers in. What I get here then is 1600 equals 100 plus 14f. Subtract 100 from both sides. Equals 14xf, not f. Divide by 14, and we get xf then equals 107.1 meters. Well, hey, some of this I'm sure is really confusing. Some things that we need to know is we have to have constant acceleration. Remember, if they don't give you time, you're probably going to be using that middle equation, the one that's got the xf or vf squared and vi squared. And we're going to be working on this in class for some time now. Hey, I'll catch you on the flip side.